Hello and welcome back to another episode of Vindexx Engineering. In this episode we're going to go through and tear down the LS engine that we have. We're going to go over some of the surprises that we found, and we're going to discuss what the plan is next. Enjoy! First step in disassembly is removing the fuel injectors and the fuel injection system. Next, I remove the intake from the engine. And then I use a shop vac to clean up the debris under the intake. After removing the serpentine belt, I next start on removing the accessories off the front of the motor. Next, I remove the bracket that holds the coils to the heads. Next, I use an 8mm socket to remove the valve covers from the heads. Overall, the heads look pretty good as there's not a whole lot of junk built up inside them. After breaking loose the bolts for the rockers, I use my Ryobi impact to remove the bolts. Interesting enough, this engine has a multi-layer steel head gasket. After removing the head from the passenger side, I start working on the driver's side. This side appears to have a little bit more buildup on it and will definitely need to be cleaned before it gets reassembled. After getting the next head off, I get out my micrometer to check the bore size to see if it's a stock bore. And it is the stock bore of a 5.3. Next, I break all the bolts loose on the oil pan before using my impact to remove them really quick. After I get the oil pan off, I then work on getting the windage tray and the oil pickup removed as well. Now that I have access to the crank, I rotate it around to see this casting number on the crank. And after looking it up online, I realize this is not a 5.3, but a 4.8. So it turns out I have a all-stock 4.8 liter LS engine. Cylinder walls seem to be in good shape. A lot of carbon buildup, but nothing that some cleaning can't take care of. Next, we're about to remove a piston, that way we can check the gap on the rings. Yes, I'm looking at the bearings, and they don't look too bad. Piston has a little bit of wear and a lot of buildup on it, but otherwise looks to be in good shape. After spraying some WD in the cylinder and removing the ring from the piston, insert the piston ring into the cylinder. Use the piston to push the ring further into the cylinder to make sure that it is square for when you check the gap on the ring. That is the gap you're looking to check. The gap on the top ring turned out to be 26 thousandths. Next, we're going to check the gap on the second ring. Using the same method, push the ring into the cylinder using the piston. Depending on the application, and if you're using nitrous, turbo, supercharger, or just naturally aspirated, you'll want to make sure you have your rings gapped accordingly. The second ring gaps at 20 thousandths.